Magandang gabi sa lahat ng mga nanonood sa amin. Nandito na naman tayo ngayong gabi, linggo ng gabi. Maganda ang ating magiging talk ngayon. Kasama natin si Sir Froilan N. Guzman, isang college teacher sa TUP. Napakahusay nito. Kabatchmate namin to ni Sir Jetro sa PNU. Alam namin marami kayong matututunan. Pero bago ang lahat, ipa-plug muna sana namin yung sa darating na Sabado. Wait lang papakita ko yung picture para mas mas maintindihan nila. Ito, Sir Ryan, nandiyan ka ba? Sir?
Oo naman. Iniimbitahan po namin kayo na umattend nung gaganaping webinar tungkol sa money matters, money management. Tayong mga guro kadalasan ay nagkakaroon ng problema when it comes to finances. Hindi dahil sa kulang, kundi dahil hindi natin kadalasan alam kung paano to tamang gastahin at kung paano palaguin. So, sa October, Sir Irvin, October 3, 1 to 3 p.m. Libre po itong webinar na to via Zoom. Ang description po, ang link po ay nasa baba, Sir Irvin. Nasa baba po, i-click nyo lang po yung link dyan for registration at i-email po namin kayo para makakuha nyo yung link sa webinar October 3, that's Saturday, 1 to 3 p.m. Malaki pong bagay ito, libre, matututo kayo ng maraming bagay kung paano tayo makakasurvive in terms of finances during this time of pandemic at paano natin mapapalago ito. So, ulitin ko po, libre ito at makakatanggap po ng mga certificates, e-certificates, lahat ng mga participants. At welcome rin po yung mga OFW professionals at mga empleyado. So, kita-kita po tayo dyan sa webinar na yan. Ang magiging speaker po yung Shelo siblings. Para lang po may background kayo, sila po ay nagsimula talaga sa wala. As in, wala. Buti si Sir Irvin, meron ng mga investment yan. Kumbaga, maluwa buhay niyan. Pero sila pong magkapatid ay nagsimula po sa wala at unti-unting lumago po hanggang sa ngayon ay na sila, masasabi ng tagumpay, multimillionaire na yung mga magkakapatid. So paano po nila ginawa yan? Ito po yung isi-share nila sa atin, libre po. Magpapakapagod sila, libre, wala silang tatanggapin talent fee para po sa kanila advocacy na tulungan yung mga professional at mga teachers. So kita-kita po October 3, 1 to 3 p.m. Ang registration code and link po ay nasa ibaba po ng video.
Ayun, maraming salamat Sir Ryan. So punta na tayo sa ating guest ngayong gabi. Si Sir Froilan. Nandito rin sa ating live si Sir Jetro Gardon. Ayan, si Sir Froilan. Si Sir Jetro. Ayan, Sir Froilan, maraming salamat sa pagtanggap ng aming imbitasyon para makapag-present ka dito sa ating channel.
Thank you din sa pagbibigay ng opportunity na ma-share ko yung research interest ko. Ito related doon sa research na ginagawa ko sa masteral degree ko. So thank you.
Kilalang ni Sir Jetro tong si Sir Froilan kasi magkaklase ko sa PNU eh. Nakasama din namin itong si Sir Froilan, napakahusay nito, mabait to. At sigurado kami marami kayong matututunan dito. Di ba, Sir Jetro?
Hindi ko po kilala. Joke lang. Load ko yan.
I-share screen mo na tapos para na kami. Alis na kami dito. Kasi ikaw talaga ang man of the hour eh.
Okay, sige, sige.
Sige.
So, okay. So, gusto ko lang itanong kung okay ba yung screen? So, naka-share na ba? Na-view nyo na yung aking slides? Okay, so I think we're ready. No, we're done. Dito, okay na. All right. So, good evening once again. So, my name is Froilan N. Guzman. So, aside from faculty member of the Physics Department of TUP Manila, so I'm a current graduate student. No? I'm taking a Master of Science in Physics at De La Salle University in Manila. So, tonight, I'm going to share to you my research interest. Okay, so the title of my presentation is Trends in Photoacoustic Molecular Imaging of Infectious Diseases. So medyo timely because now we are in times of pandemic, and we know that COVID-19 is one example of this infectious disease. So it is important that one important aspect to fight this disease is early detection. Okay, and using a photoacoustic effect as a potential way or potential means of detecting detecting infectious diseases, not only COVID, but sana naman in the future, no, if there will be a potential outbreak or outbreak of infectious disease. So hopefully kapag-develop tayo ng technology, no, not only at present time but also for future for future use or okay. So allow me to start now my presentation. Ayan. My presentation outline will follow this flow or this sequence. So let's start with the first historical background about photoacoustic effect, and then what are the current trends? No? What's in? Ano ba yung uso ngayon when it comes to in the field of photoacoustic imaging technology? And then how is this photoacoustic imaging technology is applied in different research or specifically in detection of infectious diseases? And then what are the future developments or what are the things that we're looking forward in PAI technology? So PAI is a photoacoustic imaging. So with the current pandemic, so one word is associated with it, and that is a change. So there's a drastic change in our lifestyle. A new lifestyle wherein there's a less physical contact with others. And so we practice the what we call a physical distancing wherein so 2 meters or as much as possible we set a distance of 1 meter. Uh, so so less physical contact with others, and then minimum health measures are observed. So what are those health measures? So wearing a face mask. Then when you go out and you buy your goods in the supermarket, so you wear face shields. Then you will see now in anywhere alcohols, sanitizers. So diba, when you go to SMO, you're required to put or to use alcohol or disinfect or other disinfectants. And then the trend of work from home scheme becomes a trend, although I'm not saying that this is actually work from home scheme is not a new concept, but of course in aspects or in sectors like in education na hindi na tayo allow na mag face to face meeting, 'di ba? So work from home now or study from home or distance learning now is the new trend in education and in some other sectors also. Then Yan, ito yung namimiss ko, ano, less movement, okay, and then less travel. Okay, so yan, nabawasan ng ating paggala-gala. Dahil, of course, if you want to go out, so you will pass through checkpoints, but you will be you will go through an inspection wherein you need to present documents. So to avoid that, these kinds of hassles, better if you stay at home kung wala ka naman talagang gagawin. Then, okay, so infectious diseases. So these are caused by microbes like bacteria, viruses, fungi, and then parasites. So infectious diseases cause high mortality, morbidity, and financial burden. And then actually there's a projection. There's a projection that by 2050, so antimicrobial drug-resistant infections will become the leading cause of mortality globally. So there's a projection that in the future, there are a number, no, million of people, 10 million of people that will suffer. So hopefully, these projections, hindi naman siya maging pag-turn into a reality. But of course, syempre, we would like to, syempre, maging prepared din. Syempre, may mga napapabalita tayo that new viruses, new infections are now nandyan lang. No? And it's better that we are prepared to it. Okay? And then, what are the current trends or technology in disease detection? So we have this in vitro diagnostic methods. So like the reverse transcription PCR or RT-PCR. So that's in vitro, wherein the sample is being studied inside or within the organism. So for example, yung ating when our nasal or yung ating swab, the sample that is being yung kinukuha sa swab test or our blood. So testing methods like RT-PCR are gold in standards. However, these methods also suffer from disadvantages. So disadvantages like invasive tissue sampling, wherein your nasal swab and blood, these substances are taken out from your body, and when it is being taken out, there's a possibility of those samples will become contaminated. Okay, and then invasive pa. Okay? And then so invasive na pong pinapasok yung apparatus or yung instrument sa iyong katawan. Diba? So nasal swab, may ilang accounts na nagsasabi na masakit swab test kasi talagang i-scrape nila yung iyong nasal cavity. So ganun din sa blood, di ba? Of course, syringes will be used in taking blood samples from the patient or from the person being tested. And then static one-time measurement, and then time-consuming. So in the average in RT-PCR test, so it takes 2 days for results to come out. So medyo matagal. And when you are testing a large number of people, so that will become a disadvantage. So however, for early diagnosis and for developing, testing, translating various treatment options through clinical phase, pathogen-specific molecular imaging technologies are required. Okay? And then, so molecular imaging techniques. So what are the advantages? So it can help delineate the inflammation from infection. Okay? And then identify infectious pathogen. And we're going to discuss this in detail later on. And follow pathogenesis real time. So pathogenesis, this is the term I use to describe the development of disease in patients or in a person's body or system. Okay. So what are the current technologies or instruments being used in molecular imaging, not only for infectious diseases, but in general. Okay, so first is PET, or the positron emission tomography. So it's PET is the most sensitive whole body molecular imaging technology. So the patient is being placed here, and then it's, it the patient enters yung hole na yon, then it's being scanned using positron emission technique. And then clinical applications in cancer and neurological diseases. So imaging of tumors, okay, the angiogenesis or the development of blood vessels, then concentration of hemoglobin in the brain when used in, or other activities in the nervous system to characterize or to diagnose the different neurological diseases. But although PET is a sensitive, it's a very sensitive device or technique for molecular imaging. So merong disadvantages pa rin. So number one, so it's not ideal for repeated testings for the reason that PET, so the radiation that the body or the patient receives from PET is ionizing. So when we say ionizing, so this kind of radiation has the capability of alter your body structure, or your DNA, your cells, okay? And it can pose harm to you when or to a person when being exposed to PET radiation for extended period of time. So kaya nga 'di ba, kahit pag nagpapa-X-ray tayo, so there's a time interval or time duration wherein you are allowed to get an X-ray test again. So parang 6 months, or I'm not sure if 6 months at least, because radiation like X-ray, then the radiation coming from the PET, these are ionizing. Okay, so these are ionizing kind of radiation, which is harmful when yun nga, kapag na-expose ka ng for a prolonged period of time. And then another disadvantage is PET, and then yung CT scan, yung computer tomography scan, and then you have the magnetic resonance imaging. So these instruments are bulky, so sobrang laki, and expensive. So when you want to transfer it from one place to another, syempre mahirap because these are big, no? These are bulky instruments, and the deciding factor here is expensive. So not all, or not everyone can have access to these devices. Kasi kung medyo mahal, or if the hospital wants to purchase an MRI, so medyo magastos. And aside from that, the maintenance. Okay? Because for example, in the case of PET, so it requires what do you call this? So it requires a special access to cyclotrons for isotope production with long half-life. And yan, so aside from buying the MRI or the PET scanners, so you need also to purchase this kind of cyclotrons to produce an isotope with the specific characteristic na dapat yung half-life ng isotope na yun ay matagal para hindi agad siya mag-decay or mawala or mag-disintegrate. And then, there is a need for non-ionizing, non-invasive, portable, and real-time molecular imaging technology. So, if we try to enumerate these characteristics of an effective and safe molecular imaging technology kumbaga it feels or it makes up doon sa mga disadvantages ng mga nauna nating binanggit na measuring or the molecular imaging devices or instruments. So non-ionizing dapat safe na kahit paulit-ulit, no? Pwede siya for repeated testing. Then non-invasive, of course, as much as possible, walang pinapasok or walang tinutusok sa katawan. Portable, so that means can transport or you can yung logistics, hindi siya madaling hindi siya mahirap ibiyahe. Then real time. So real time, once you after the testing, so para mismo meron agad na results. Excuse me. And then yan. So there is an imaging technique which satisfies or which is qualified, no, for this qualified for this character. Kumbaga pasado siya in these qualifications. So we call that imaging technique photoacoustic imaging. So it's a hybrid technique. So hybrid meaning a combination of two imaging modalities. So actually the word photoacoustic is a combination itself of two words. So photograph, we have the photovoltaic cells. So the word photo is something that is produced by light, by a picture or the photograph. Is one example. And then we have the acoustic. So when we say acoustic, so something that is related to sound. Then combining these two words, we have photoacoustic, meaning sound produced by light. Wow, so pwede ka palang lumikha ng tunog gamit ang liwanag or ang ilaw. So analogous. So in analogy, so we can think of thunder produce yung kulog na nalilikha after matapos ang kidlat, no? Kulog, then ano ba mauuna? Kikidlat muna, so that's lightning, and then afterwards, so the sound of thunder, the rumble of thunder follows yung lightning. So we can think of it as an example of a photoacoustic effect, a result of a photoacoustic effect. Okay? So, kailan? Yan. So, how does a photoacoustic effect works? So, let's consider the figure on the left side. So, we will see the laser pulse as the source of light, or the one that illuminates the sample or the region in a body that we want to examine. Then, so, halimbawa, ito yung tissue or ito yung sample, no, this pink object here. Then you will see the blood vessels, itong mga red lines. And then, for example, if we want to target or if we want to characterize, halimbawa, yung hemoglobin, so the component of the blood that carries oxygen. So the laser pulse or the hemoglobin will will receive light or ma-expose siya sa light, and in turn, so we know that light is a carrier of energy. So that's why we feel there's an increase in temperature, or we feel hot when we expose ourselves in sunlight, or di ba, sa gabi, if you experience taking care of chicks or yung sisiw, di ba, we expose or the caretaker will allow these chicks to get exposed in a bulb, in light coming from incandescent bulb at night. So that is to increase the temperature inside the cage, because light carries, it is a carrier of energy. So the hemoglobin will absorb energy. Okay, so magiging hyper. So as a result, the hemoglobin or the sample will oscillate or it will experience vibration. And then this vibration in turn produces mechanical waves. And these mechanical waves are the ultrasound waves, which is collected by the ultrasound detector. And this detector, ultrasound, is connected to a processing, to an image processing device, and then a computer to interpret. Because these ultrasound waves contain information about the image that we would like to produce. So here in this next figure, so the absorber or the sample absorbs energy from light or from the laser. So we choose laser because unlike sunlight, so the laser is monochromatic. So monochromatic meaning yung kanyang energy or yung kanyang direction, yung direction ng ilaw ay nakafocus lang sa kumbaga hindi siya scattered or hindi kalat-kalat na yung direction ng light waves. So monochromatic. So like a laser, it's monochromatic. And then laser illuminates the sample. So the absorber absorbs energy, of course, and then it produces mechanical waves that is being tapped or collected by the detector, ultrasound detector, and then the computer will process the information contained in the ultrasound waves to produce this kind of image, which we call a photoacoustic image. Okay, so we call the mechanical waves produced by the vibrating tissue as the photoacoustic waves. Okay, so some history about the photoacoustic effect. So it goes back to 1800s, late 1800s, when Alexander Graham Bell was experimenting with long-distance sound transmission. So here's a picture of his invention that is called the photophone. So photophone, so phone, so parang it's a device for communication, right? Okay, so he transmitted vocal signals by reflecting sunlight from a moving mirror to a selenium solar cell receiver. So this is how it works. So here, so I hope yung mga audience natin can see my arrow, itong aking mouse cursor. So here is the mouthpiece wherein, of course, kung may gusto kang sabihin, so you place your mouth or you place your mouth near this mouthpiece, and then so the sound waves will travel from the mouthpiece going to this mirror. So here, okay. So as a result, this mirror will oscillate or it will vibrate according to the sound that you produce. Kumbaga, 'di ba, pagka matinis or pag sobrang lakas ng boses, 'di ba? May nagba-vibrate or it causes some movement. So same here. So the mirror is sensitive enough to vibrate when sound waves coming from the mouthpiece is being directed to the mirror. Okay? And then so there's another mirror. Wait. So but before that, so the same mirror, so the one that picks up your voice or your the sound waves that generated by your speech. So it will there's a light source that will pass through, or the light will illuminate that mirror. Okay? So habang nagba-vibrate yung salamin or the mirror, so nasisinagan siya or na-expose siya sa light. Okay? And then so that mirror, that same mirror will reflect the light to another mirror. So mirror A, tapos kumbaga first mirror tapos ma-expose siya sa light source, and then habang naka-expose itong si first mirror at habang nagbabibrate siya or the mirror, the light initially coming from or initially na naka-point or naka-directed to the first mirror, that light is being reflected to the second mirror, which is B, okay, si mirror B. So in turn, so that mirror will, kumbaga, it will receive the information coming from the first mirror. So habang nagtatransmit ng light si first mirror, nagbabibrate siya. So that same vibration will be picked up by the second mirror as kumbaga, gumagalaw. Tapos nag-send siya ng message or na-expose siya sa light. And then that same vibration will be, kumbaga, it will be carried out by the light reflected by the first mirror going to the second mirror. So, yung information ngayon, the sound is being transported or being transferred to the next mirror as, kumbaga, nag-transfer yung sound through light. Okay? And then, the second mirror now picks up the message, so the reflected light, and it is connected to solar cell receiver, and the solar cell receiver will interpret the message, and that the sound wave that is being carried by light is being interpreted by the solar cell receiver and will be converted again to sound. Kumbaga, the message initially in the form of sound, being from sound converted to light, and then from light again being converted to sound. So that is how a photophone works. Okay, so if we think of it, this is similar to the present day telecommunications, wherein we are receiving messages using our wireless phone, where we are able to connect to the internet wireless using our Wi-Fi router, because this information now is being transmitted using not only light but other forms of electromagnetic radiation. So for example, if you're watching in a TV, so the message is transmitted through radio waves. Okay. So if you're using satellite broadcasting now is possible because of these messages or information. Pwede nang i-convert to EM or electromagnetic wave or radiation. Okay? So parang isipin natin, dito nanggaling yun, yung mechanism or the technology. Ito yung first known technology of sending messages wireless. Okay, using wireless device. So photoacoustic imaging technique offers high depth. So that is 1 to 5 cm. So that this is one advantage of photoacoustic over other imaging modalities, because we know that light, there's a loss in intensity of light as it pass through the sample. So as it goes deeper, so yung intensity ng light ay humihina. Kumbaga yung intensity or yung liwanag humihina habang lumalalim yung kanyang naaabot na depth. And then aside from that, so other phenomenon like diffraction, so nagkakaroon ng bending of light, and then there's also what we call attenuation, wherein there is a loss of signal when the light or the EM wave goes through the sample. So those limitations are being overcome by this method, photoacoustic imaging technique. And then, aside from high depth, or it can penetrate high depth, can also produce images with good resolution. So 1 micron to sub-millimeter. So micron is around 1 part or 1 part of a million, or one, or so that's point 0.00001. So 6 zeros, and then meter, so 1 micron, so very small. And then if you go through higher depths, so the resolution reduces to a sub-millimeter. So sub-millimeter resolution is still good, no, relatively. And kasi sa image processing, the smaller the resolution, the better. Okay. Kasi kapag malaki yung spatial resolution, so diba nagiging pixelated yung image. So that's the idea. And then usually the target are the light absorbing chromophores. So these are biomolecules that is kumbaga, when these are exposed to light, they are very reactive, or can easily determine, or you can easily see yung kanilang reaction. Okay. They easily react when subjected to light, okay, or laser. And then in the past 20 years, photoacoustic imaging technique is this is a research field or research area in medical imaging. That is this field is on the rise. Okay, so applications, there are wide applications, or various applications of photoacoustic imaging. So there's an application in cancer, so tumor angiogenesis, so the development of blood vessels in the tumor, then cardiovascular, so plate lipids, okay, so yung mga fats, the lipid deposits in our blood vessels, and then neuroscience, so medical imaging, so to determine or to produce an image that will show cerebral blood flow and oxygen saturation. So oxygen saturation is related to oxyhemoglobin. Ito yung part ng blood, the oxyhemoglobin, that carries oxygen, which makes our blood red. Okay, blood color red. So the quality of the image contrast can be improved by using external agents. So sometimes, aside from this light-absorbing chromophores, for example, if you want to diagnose or to take a molecular image of, for example, fiber, or a certain, aside from this, a certain tissue, so you need external agents, because it improves the image quality, the image contrast, without actually affecting the tissue. Okay. Kumbaga sa picture, pinapaganda niya yung quality without affecting kung ano yung nandun sa picture, doon sa photo. Okay. So, we mentioned many imaging modalities, many imaging techniques in the previous slides, but why? What makes photoacoustic imaging a better choice, or a more mas advantageous compared to the previous ones? Because unlike ionizing X-ray radiation, okay, so photoacoustic imaging, so it uses basically it uses EM waves, or electromagnetic waves. So It has a low intensity. Okay? Low intensity, so meaning yung energy being carried by this photoacoustic imaging technique is less or lower compared to X-ray. And then it poses no health hazard and at the same time provide new contrast mechanism. Okay. So photoacoustic imaging combines electromagnetic and ultrasonic waves synergistically, providing relatively deep speckle-free imaging with high electromagnetic contrast and high ultrasonic resolution. So we can think of this as the photo aspect or the photoacoustic yung light part ng photoacoustic imaging, it makes up yung pagkukulang ni ultrasound. Kasi kapag acoustic lang, so technically we are using ultrasound modality of imaging. So you can think of it as photo and then acoustic. So kumbaga yung kulang or yung shortcoming ni photo is being filled, nagfi-filled in or being complemented by the acoustic part. And then the shortcomings of the acoustic part is being complemented by the photo part, which is they complement each other. So the result, it provides it provides imaging technique with deep speckle-free. So speckle, yung mga artifacts, yung mga discoloration, or you will see components sa image na wala naman talaga or hindi naman talaga siya nag-exist, yung speckles. So speckle-free, so the imaging that is provided by the photoacoustic imaging technique, and with high electromagnetic contrast. So the image resolution is good. The quality of the image is good. So potential impact of photoacoustic imaging in detection of infectious diseases. So the image to effectively image pathogens. Okay. So ito yung mga nagko-cause ng disease. And understand the pathogenesis. So imaging technology should be sensitive. Okay, so photoacoustic imaging, check. Then prognostic information extracted may also improve treatment of the infectious disease. So when we say prognostic information, so this information can actually can tell an expert or a doctor about the course or kung ano yung what is the course of the disease or how the disease will develop in a patient. Okay. So if the imaging technology is good, if it is sensitive enough to detect or to diagnose how the disease develops in a patient, so the scientists now or the doctors can gather enough data to use it in formulating prognostic information. Okay. And then there are three key areas in detecting the presence of infectious disease. So number one is pathogen-specific diagnostics. Then number two, pathogenesis, or ito yung it describes how will the disease develop or ano yung course of action or ano yung magiging what is the yung course of action as time goes by. And then of course the last part will be what is the role of detecting these diseases in treatment planning. So nandiyan yung development ng vaccines, okay, how to kumbaga, how to provide or how to formulate solutions or how to provide solution using yung early detection ng disease. Okay. So, so for pathogen specific diagnosis, so when we say pathogen specific, dapat yung photoacoustic imaging tool or yung technique is designed to detect or to take an image or to kumbaga para differentiate or para ma-identify niya yung pathogen sa loob ng katawan ng patient. So, the imaging technique should be able to distinguish bacterial cells from host mammalian cells. So, in the case of photoacoustic imaging technology, so it can target multiple binding sites within the mammalian cell. Kasi kapag isang binding site lang, so paano kung hindi ma-distinguish doon sa specific binding site na yun yung difference ng bacterial from host mammalian cells. So it should be there are multiple. Okay. So it should be a multiple binding sites, okay, within between the bacteria and then host mammalian cells. Okay. Then next, for imaging viruses, which are much smaller than bacteria, so photoacoustic reporter genes may yield better results. So photoacoustic reporter genes, so these are proteins or amino acids na nilalagay sa sample. For example, a virus, okay, that when kumbaga sa animal or kumbaga sa isang organism, pag nilagay mo tong reporter gene, so it will, so that virus or that the bacteria will exceed or will kumbaga papakita niya or will demonstrate this characteristic without affecting the virus or the cell. So it will exhibit these characteristics when infused with reporter genes, but not actually but it doesn't affect yung mismong gene, so hindi niya pinapahina or pinapalakas. Okay. So the purpose of using reporter genes is to aid or to help the photoacoustic imaging technique to become more effective. Kasi kung yung virus or yung bacteria na yun ay makakapag-exhibit or makakapag-present ng ganitong characteristic, so it's very easier for the photoacoustic imaging technique to differentiate or to diagnose na this is the target cell or this is the target virus that we would like to observe. Okay. Then pathogenesis. So photoacoustic ultrasound scanner can provide non-invasive imaging of deep-seated infection, inflammation, and immune responses. So there's a technology now that combines, kumbaga, it's a multimodal imaging modality that aside from photoacoustic, so pwede kumbaga photoacoustic and then ultrasound is combined into a single device that for example you can turn on yung settings lang ng photoacoustic imaging, or if you want you can use yung yung ultrasound option ng device. Ang tawag doon ay multimodal. So not one but two. Okay, so it's a combination of photoacoustic and ultrasound. So we call that a PAUS scanner. So how does it work in in diagnosing or observing yung pathogenesis. So, for example, in a lung infection, in a pneumonia, you can observe or you can take a molecular image using, for infection, you can use the ultrasound setting of the scanner to get the image or to diagnose yung severity ng infection. But if you want to observe, for example, the movement of virus within the lungs, so use the photoacoustic setting or the photoacoustic mode of that scanner or imaging device. So it is flexible, no? Because it can observe or it can detect, okay, the development of the disease. If there's a lung infection, so pwedeng ma-observe, okay? Or if you want to observe the virus, so pwede mo ring ma-observe or ma-detect. Okay? So that's one advantage of PAUS or photoacoustic ultrasound scanner. So not only the virus, but how the virus affect the organ or the part of the body that you would like to examine. And then, treatment planning. Photoacoustic ultrasound scanner can help identify suitable antimicrobial treatments. So follow response to treatments and health vaccine development. So here, this is important, no? Especially when this is important, lalo na kapag there's a treatment or there's a vaccine being developed. Because you can actually image yung mga immune cells in the body. So when a patient is being, when a vaccine is administered to a patient, so how will the immune cells react or how will they behave when when the vaccine or the treatment is being introduced to them or to the cells? So, paano sila magre-react? So, kapag positive yung reaction or if the response of the immune cells or the body is magka-positive, so in a way, so the scanner can identify or can help tell yung mga developers or yung gumagawa ng vaccine that this vaccine is effective or it doesn't pose any harm doon sa patient. Okay. So by telling or by detecting the response of the immune cells when being introduced to vaccine or treatment. And then how about the future developments in photoacoustic imaging technology? So, number one, so the deciding factor in building a photoacoustic imaging setup is the cost. Because right now, the one photoacoustic imaging setup cost 80,000 to 800,000. So not in pesos but in US dollars. So relative, so mahal pa rin, ano? But mas mura compared to if you will buy an MRI or a CT scan or a PET scanner. Mahal, no? Millions of pesos, para 80K or $80,000 is around 4 million pesos. Mahal pa din. But the experts now in photoacoustic imaging, so they are studying or they are trying to construct or to build a setup that is cost effective, so much cheaper, okay, compared to yung mga available photoacoustic setup na available na sa market. So that's one challenge. And then performing clinical trials, because sa lahat na nabasa ko na literature, this photoacoustic imaging technique or technology is administered to animals, being their participants or subjects of the experiment. So, yun nga, no, dapat, of course, so to determine if kung yung effectivity nung nung study or nung technology, dapat makapag-perform din ng trial sa ano talaga, human patients. Okay? And then, number 3, the choice of photoacoustic external agents. So, you can choose dye or a carbon nanotube or gold nanoparticles. So, depende. But remember that this photoacoustic external agents depende sa gamit, or kasi may ibang agents na halimbawa safe siya for this purpose, but when used to animals, toxic. So this is a crucial part then of if you want to use a photoacoustic agent. Okay, and then compact photoacoustic imaging setup. So dapat yung we are ako din, I would like to develop in the future setup na halimbawa pwede siyang isakay sa cart or madali siyang i-transport from one place to another, kasi kapag so medyo challenge din, no? Because what you're going to do is kasi may iba't ibang components yan. You have the computer, the image processing, the digital data processing, then you have also yung laser, of course, the computer, and then if there's a scanner, a moving scanner for your laser, and then dapat medyo mahirap yun kung isa-isa individual components of the setup you're going to arrange or to kumbaga i-set up mo siya sa isang lugar. So kailangan kasi dapat yung laser naka-align, kasi kasi maliit lang yung beam size eh. So dapat sakto na naka-align para when the laser is turned on, dapat straight siya doon sa sample. So dapat careful with the alignment, tapos dapat yung XY scanner precise din yung pagka-setup. So much better if there is a compact imaging setup na halimbawa meron ka na lang handheld probe or yung parang barcode scanner, di ba, sa mga department store. So instead of ilalagay pa sa platform yung sample, so iyan mo na lang parang yung temperature scanner. So itapat mo na lang doon sa area or sa region that you would like to examine. So compact siya. Okay, so kapag compact, mas madaling gamitin. So I will show to you a sample paper, a sample research wherein a genetic reporter that is tyrosinase base is ito yung external agent, the tyrosinase. Okay, it's an amino acid, or it's a protein that synthesizes eumelanin, or this is a pigment that makes our hair and our skin dark, so black or brown. So okay, so here, so this was taken from a Nature Photonics publication. Yan. So ito yung tinutukoy ko na individual components nung setup. So you have the laser, okay? So you must be a tunable, then so nandyan yung integrated heater and then thermal chamber. So this materials, so you need to set up, at hindi lang basta dapat i-set up. So may alignment ka pa na dapat sundin. Tapos of course these are measuring tools, or so you need to calibrate also. Then in the study, So we'll see a mouse. Yeah, so the excitation light, so that is being provided by the pump laser, and then we have the XY scanner because if you want to examine a large area or kumbaga, kung malaki yung iyong region na i-examine, so you need the XY scanner. And then here, instead of using the traditional piezoelectric scanner or yung ultrasound scanner, so a Fabry Pero sensor head is being used. So there are dichroic mirrors placed between a layer of polymer, and then yung sensor interrogation beam, so that is the one that carries the information. It carries the information about the image, okay, that we would like to produce or examine. And then, so just focus dito sa picture na to, sa letter C. So here is the sample or the cells that is being infused with tyrosinase. So again, so the reason why it's dark in color because tyrosinase it produces eumelanin, and the eumelanin is pigment that is dark or brown in color, dark or so dark shade like that or brown in color. Then, so here are the results. So here's the region we're in. So ang ginawa kasi dito, so merong, teka, okay, andun siguro sa next. Ay, wala. So ang ginawa kasi dito sa study, so merong target cell, tapos yung, ayan, yung nakikita yung yellow mass na yan. So that's a tissue. Oh, sorry, that's the target tissue. And what they did is they introduce tinatawag nila na retroviral vector, or kumbaga ito yung, it's a virus that will carry yung reporter gene, which is the tyrosinase, in the cell, and then you will see that as time goes by, yan, hindi pala dyan, dun sa next slide pa, that as time goes by, yung area of infection of that virus, so that virus that carries the tyrosinase reporter gene, so nag-i-increase in size. Kumbaga dumadami yung cell na nai-infect ng virus. So here, I will see, yan. So the depth is given by this, yan, itong color chart natin. Okay. So here are, these colors are, meron tayong tinatawag sa imaging na false color representation. So it is not actually the color of this image, pero yung kulay na yan ay ginagamit lang to represent the depth or gaano kalalim yung region or yung image na kinuha natin. Gaano siya ka-deep. Okay? So these are just false color. And then here, ito yung sinasabi ko na, yeah, so the number of infected cells in the tissue increases as time goes by. Ibig sabihin, yung virus that carries that reporter gene, its number increases with time. Okay. So the relationship is almost linear. Okay. So aside from the small error bars. Okay. So volume taken up by tyrosinase expressing cells. Yun. So yun ang papel ng reporter gene, or that's the role. So that is to help or to aid the photoacoustic imaging setup to identify or to differentiate the target cell from the rest of the tissues or from the rest of the the blood vessels, the other chromophores, para ano siya, mabukod. Okay, so it is easier to detect kung madali siya ma-differentiate with other chromophores or other components in the tissue. Okay, so here are my references. And then I would like to share that aside from being a part of the Faculty of Physics Department in TUP, so I'm also a graduate student and I'm a part of the DLSC Optical Society and Optic Research Group. So here is our group. So I'm here wearing a polo, maroon polo, and then here's our advisor, Dr. Romeric Pobre, and then the rest are my group mates in the laboratory. Okay, and then actually this photo, okay, so photo, right? This photo was taken 3 years ago, and at present we have how many members? 20. So there's a growth in the number of participants or of lab members in our research group. And then here is a picture, so of us, no, DLSC Optical Society attending workshop in LaSalle. So it was hosted by the Computational Materials and Design Research Group. So it was the workshop was spearheaded by representatives from a university in Japan, tapos a university in LaSalle. And then some of our events in DLSC Optical Society. So again, this was almost 3 years ago. We're in here are the officers. So during that time, I was the external vice president of DLSC Optical Society. So we invited Dr. Reyna Bel Reyes. Dr. Reyes is one of the 3 astrophysicists in the country. So it's an honor of having her as a guest during that time. So, if kung meron man sa inyo sa inyong mga audience na you're pursuing a degree in STEM or you're teaching in teaching STEM subjects, so importante na yan. So we enroll sa graduate school kasi maraming experiences. I'm telling you guys, ang daming experiences na binigay sa akin ng pag-attend ng graduate school. So you will not hindi ka lang ma-develop academically kasi you will take advanced studies, but also I will meet people na not only from College of Science but other colleges as well. So parang pag iniisip ko nga dati na yung graduate school siguro is more on individualistic yung approach, but actually it's not. Depende sa so we work in the lab together. We organize our events together. So parang ganun din, may peers ka rin, may barkada ka rin sa graduate school. So that's exciting part dito sa aking journey. Okay? And with that, would like to take this opportunity to thank once again Sir Irvin. So thank you, Sir Irvin, for giving me an opportunity to share my ideas. And then thank you din sa mga audience na nakinig to. I hope you learned something tonight. So thank you, sir. I-ano ko na sa'yo, i-turn over ko na sa'yo.
Ayun. Thank you, Sir Froilan, sa sa napakagandang presentation.
Okay, thank you, sir. Thank you.
Napakahusay talaga. Kasi itong presentation ni Sir Froilan, naniniwala ako na beneficial to sa lahat ng mga pre-service teachers na kumukuha ng physics. Kasi gaya nga ng sinabi natin, di ba? Ang goal lang naman natin dito ay makatulong, kumbaga makagaan ng kahit papano sa mga teachers, sa mga magulang, at sa mga estudyante. regardless of kung ano man ang kanilang kinukuha. Sabi ko nga kay Sir Jetro tsaka kay Sir Ryan, before pa, kahit isa lang ang manood ng video na ginagawa namin, tutuloy-tuloy pa rin namin. Kasi kumbaga hindi naman ito basehan ng maraming nanonood o konti yung nanonood eh. Kasi sa isang advocacy, basta meron kaming isang tao na matulungan at maturuan, okay na kami doon. Kaya maraming salamat Sir Froilan. Sir Ryan, baka meron kang gustong itanong sa Sir Froilan sa napakaganda niyong talk.
Sige, open na yung floor for questions.
Sa sobrang ganda ng nung presentation, masyado ako na-overwhelm eh. Kumbaga, ito, fusion. Kumbaga, fusion ng ng medical science, at saka ng physics, ng natural science.
Yes,
So,
sir.
kumbaga, bago kasi sa pandemic eh, actually ngayon ko nga lang na-realize ko nga, pwede pa lang yung light ay mag-create ng sound kung paano yung kulog ay nabubuo mula doon sa kidlat.
Yes,
So, personally, wala akong pero yung mga suggestion mo, Sir Froilan, napakaganda, lalo na doon sa, yung development nung mga scientific and testing equipment para sa sa medical science. Sana ma-revolutionize nga yan, at maging affordable para do sa sa lahat ng tao.
Okay, thank you, sir. Thank you.
Sir Jetro, baka naman meron kang gustong itanong o kaya suggestion mo kay Sir Froilan.
Sir Jetro. Go ahead.
Ayun, very interesting, informative, timely topic. May question ako number one,
Sige.
anong status ngayon ng development niyang photoacoustic imaging ngayon, lalo't very timely siya I mean, yun nga yung comparison natin dun sa ibang ways of imaging na invasive, yung maaring ma-expose sa matataas na radiation doses. Ito promising kasi nga we were just using yung mga electromagnetic waves na mababa ang energy, like yung visible light, no? So ano na status niyan, sir, kung ano na yung ano na yung naabot nung recent studies kung paano maging cost effective yung process niyan ng photoacoustic imaging.
So for now, I read in the literature na aside from laser as a light source, so merong nag-try na rin na gumamit ng light emitting diode, the LED na yung alam natin. But the problem is since the light compared to laser is less monochromatic, so meaning yung intensity na yung light ay scattered ang direction in all directions. So it can detect or it can take images using the photoacoustic effect. But yun nga, yun yung challenge din ngayon. Yung phenomenon kasi ay known na na-discover na Ang challenge ngayon is yun nga to make a compact, cost-effective setup. So they are trying to use other light sources like LED or cheaper variations of laser. Kasi ang nagpapamahal dyan sa setup talaga yung laser system actually nung nagtingin ako ng price for my research, yung isang unit pa lang, isang component pa lang ng laser system ay 700,000 na. So napatanong ako sa sarili ko, makagraduate pa ba ako? Pero yun nga, yun yung isang challenge. So LED then when it comes to yun naman sa kayang i-detect. So aside from ito kasi titignan as a potential in detecting infectious diseases. Kasi yung RT-PCR basically ang ginagawa niya ay kumbaga ma-detect yung presence nung virus sa RNA natin doon sa ating swab or doon sa ating nasal swab. So, pero ito kasi ay imaging. So, hindi ka lang nagde-detect ng presence, kundi you want to take a picture of what's happening doon sa loob ng doon sa sample or doon sa loob ng katawan ng patient. So, promising, but of course there are challenges, and ayun naman with the advancement din ng sa computer, for example, yung power ng computer, and syempre yung laser system din, siguro in a couple of years mas mura na siya, no? Kasi mas available na yung technology, mas accessible na. So let's see, exciting tong part na to ng research. Yun, sir.
Ganda, ganda.
So,
Sir Froilan, pwede mo Sir, kasi sa lahat ng research, kasi tayo naman bilang mga educators, hindi
Yes,
naman
sir.
nabasa sa atin ng research, action research, thesis, yung mga ganyan. Pero we would like to know, syempre, tanong din siguro to ng mga viewers natin. Mga viewers natin, pwede tayo magtanong, ha? Tapos kasi, Sir Froilan, itong video na ito, hindi lang mga live viewers yung makakapanood. Kadalasan, mas marami nga nanonood yung pagkatapos Baga yung mga replay, marami nga nanonood yan So ang tanong ko, Sir, ano yung deepest why mo kung bakit ito yung napili mong topic? Ano ba ang nakikita mong problema? Kasi di ba sa research, you are answering a question. Kumbaga, you are giving solution to a problem. Ano ba yung nakikita mo dati or na-experience mo o nakita mo, kumbaga naging inspiration mo kung bakit ito yung napili mong topic?
So ano lang talaga, interest lang. Interest dun sa physics, and actually, yun nga yung challenge din sa paghahanap ng research topic kasi ang dami mong pwedeng gawin But of course, there is a support group that will help you. Andyan yung lab thesis advisor mo, then that will guide you na ito yung research direction na dapat mong i-take, or better na ito yung i-take mo na research direction. Actually, when it comes to inspiration, it's pure interest talaga when it comes to physics. And yun nga, isa pang method ay isa pang reason ay maraming patients na they find it hard or difficult to access yung mga imaging modality techniques, like yun nga, magpa-PET scan ka, syempre may corresponding expenses yun or gastos. Ganun din kung magpapa-CT scan or some other imaging techniques na relatively mas mahal yung presyo just to get examined by those instruments. So in the future, I would like to construct imaging technique or imaging technology na mas cheaper, and then mas portable, na pwede mo siyang dalhin kahit sa mga remote areas, sa mga baryo, sa mga probinsya, sa bundok, na alam mo yun, na kahit na nandun sila sa mga far-flung areas, may access pa rin sila sa technology. Yun yung vision ko din na so aside from interest, sir.
Okay. Sir Froilan, basa muna tayo ng mga comments dito sa may mga nag-comment kasi. Si Sir Paul, ayun nga, heart daw. Si Ma'am Rizal, heart daw. Si Sir Francia ba to, Sir?
Sir yung mga yan, sir.
Heart talaga. Pero may tanong si Sir Francia. Sir, ano pong frequency ng ultrasound at wavelength ng laser po na gagamitin nyo po? Salamat.
So it depends on the imaging. It depends on your target chromophore. So halimbawa, iba-iba kasi yan halimbawa, iba yung frequency ng laser na iba yung frequency ng laser light na kailangan mo. Halimbawa, kung ang target mo ay hemoglobin or ang target mo lipid. So nag-iiba siya eh. Halimbawa sa sa hemoglobin, so it goes from 500 to 700 nanometers. So wavelength, yung ganong wavelengths so depende. Tapos sa dito naman sa ultrasound, it depends on yun nga no, kung tawag dito, kung nakadepende sa yung target chromophore, yung tawag dito, yung laser. So ganun din, no? I-adjust mo rin yung specifications nung frequency ng iyong ultrasound transducer. So actually it depends. I cannot tell I can tell a specific value or amount. So it depends.
Thank you, Sir Froilan. Sir Ryan, Sir Jetro, baka meron kayong gustong sabihin kay Sir Froilan or baka may tanong pa kayo? Sir Ryan muna, Sir.
Hindi tanong yung masasabi ko, kundi pasasalamat sa Sir Froilan sa pag-share ng iyong expertise regarding dyan sa dinidevelop. Actually, meron ng technology yan, pero dahil sa'yo, mas naging aware ngayon yung public tungkol dyan. Kaya salamat dyan sa pag-share ng yung idea regarding sa research
Okay, thank you
ng
din, sir.
Photoacoustic.
Thank you.
Ayun. Ikaw, Sir Jetro, any final message? Sir Froilan?
Hingi lang tayo ng message from Sir Froilan sa mga aspiring scientists, physicists, na yan, mga ganyang bagay yung kanilang inaaral. Very timely, very helpful. Lalo ngayon, nare-realize ng maraming tao na gaano kahalaga yung mga scientists. Di ba? Gawa nung nangyayari ngayon, Sir Froilan.
Just pursue yung interested na kung interested kayo sa STEM, if you would like to pursue a career in science or pursue a graduate study in a university like in LaSalle. So ako naman talaga wala naman akong financial capabilities kung sa sarili ko lang ako magre-rely, but I'm very fortunate then that I was a recipient of DOST scholarship. So maraming means para ma-push nyo yung dream ninyo. At kumbaga, kailangan din malakas lang din yung loob mo. Kasi nung una, I'm afraid of taking pure science as my pure physics as my major, kasi nanggaling ako sa ang undergrad degree natin, Jetro, di ba, ay BSE. So maraming kulang na mathematics, but alam mo yun, yung interest, ito yung magpupush sa inyo sa next level. And if you're worrying about the means or lack of pera, hindi ako makakapag-enroll dyan, or wala akong capability para masustain ko yung passion ko, yung interest ko. So maraming tutulong sa inyo, maraming means. Talagang kailangan lang palakasan lang ng loob yan talaga. Tapos, just pursue your dream and interest, and it will take you to places. Yun. Talagang, yun ang natin. Tsaka syempre, always prudent. Pray. Okay. So, yun lamang po, sir.
Sir Froilan. Sir, last na to. Ano ang final message mo kasi syempre ang viewers natin talaga dito, parent, sabi ko nga, parent, teachers, and students. Ano ang final message mo sa kanila or advice man lang after watching this episode? Kumaga parang any suggestion? Syempre, humaharap tayo ngayon sa bagong normal. May pandemya tayong hinaharap, maraming pagsubok ang hinaharap ng sektor ng edukasyon. Ano ang iyong masasabi sa kanila bilang isang guro? Katulad ngayon, nagsisimula ka na sa sa pagtuturo, di ba? Sa PUP, na-experience mo na ngayon yung bagong normal. Kumaga, ikaw, nararamdaman mo na yung challenges eh. Pero ikaw bilang guro sir, ano ang iyong masasabi sa kanila?
Okay, ano lang, just be patient kasi yun nga, we are entering a new normal. So, kumbaga, drastic yung pagbabago lalo na sa sektor ng education na tayo sanay na, kumbaga, ang kinalakihan natin ay face-to-face talaga na interaction. But for now, talagang hindi siya pwede. Just be patient and tawag dito, kasi hindi lang naman sa part ng students, hindi, ang struggle or yung difficulty sa adjustment ay on both sides sa part ng student na syempre kailangan ng kailangan niya mag-aral ng hindi niya kasama yung mga classmates niya, hindi niya nami-meet personally or face-to-face yung teacher niya. Ganun din sa mga teachers na todo prepare ng materials, syempre gumagawa ng paraan, ng quiz para gumagawa ng mga assessment tool to make sure na may integrity pa din na hindi nagkokopyahan, ganyan. So, it will take time and be patient na. Tsaka, isipin natin guys na na hindi naman, although syempre nandiyan na sa sistema natin yung online learning, yung module learning, pero ako naniniwala ako na na hindi naman to talaga magtatagal ng 10 years or 20 years. So, tayo naman mga tao, isa sa mga characteristics natin kung ba tayo nakasurvive ay yung ating ability to adapt. So, it takes time, but just be patient. Ako nga, personally, ang dami kong preparation na hinanda, pero alam mo yun, makaka-experience ka pa rin ng difficulty ma-experience mo talaga yung struggle pag ando ka na mismo sa sitwasyon. So, ganun din, no? Yung pasukan sa DepEd ay October 5. So, for the first few weeks, medyo pakiramdaman yan. But hopefully, lahat naman tayo, kumbaga magsasubside naman lahat. So, patient lang. Tsaka, medyo hindi natin yung yun, pag-unawa. Lalo na sa atin mga teacher. Kailangan malawak ang pag-unawa natin kasi yung mga students natin, iba-iba sila ng iba-iba sila ng pinagdadaanan eh. Kaya, yun, habaan ng pasensya. No? Ayun lang, sir.
Yun. Thank you, Sir Froilan, sa gabing ito. Maraming salamat kasi, kumbaga, nag-abala ka. Kumbaga, maraming oras ang aming kinuha sa iyo. Alam namin, napaka-busy mong tao. Sir Froilan, kapag may oras ka, gawin ka naming guest analyst sa education weekly updates, yung mga balita tungkol sa edukasyon. Kapag may oras ka, kunin ka namin ha. Sir, okay lang ba 'yon? Kapag pag may oras ka?
Available naman tayo. Sige, sir.
Thank you, sir. Sir Ryan, baka pwede mong pakilala yung magiging speaker natin for next Sunday?
Iniimbitahan ko po kayong manood ng dito sa channel ni Sir Ervin sa next Sunday. Tatalakayin po natin ay tungkol sa sports ng powerlifting at mag-guest po tayo ng atleta at ng opisyal regarding do sa development. So far, Sir Ervin, hindi ko muna i-reveal yung pangalan ng ating mga magiging guest kasi kinakausap ko pa. So, hopefully na ma-invite natin sila rito para malaman naman ng tao, maging aware sila na hindi lang weightlifting ang sports na kung saan talagang nagko-compete at nananalo tayo sa buong mundo. Champion rin tayo sa ganyang sport. So, yun ang pag-uusapan natin sa next Sunday.
Ayun, maraming salamat Sir Ryan. Gaya nga na sinabi natin, iba't ibang education-related na mga guests ang ating mga iniimbitahan dito. Hindi lang guro, pwedeng estudyante, katulad nga ng sinabi ni Sir Ryan, student athlete 'yon. Meron din tayong magulang, marami. Kumbaga, firing in all cylinders kasi kailangan nating magtulungan, hindi maghilahan pababa kasi nandito na tayo sa bagong normal ng edukasyon. Maraming salamat sa mga nanood, sa mga live viewers natin at maraming salamat din sa mga manonood ng replay na ito. Thank you Sir Froilan sa gabing ito. Thank you Sir Rian. Okay, and thank you Sir Jetro. Dito na po magtatapos ang aming programa. Maraming salamat po at see you next Sunday. Thank you po.
Thank you.